Hi everyone, my name is Anvita Bansal and we are back with another lecture based on recursion. The topic that we are going to discuss today is Tower of Hanoi. So it's very such a problem that you must have seen a lot of times, and from your SD sheet you can find this problem right here. So let me just move to this problem. So this is more of a puzzle, more than a problem. It's like a puzzle that you can understand it in that way. Let's see what is given. I'll not reiterate the question. Let me just move directly to the test case and help you understand. Before that, let's see if you guys are able to see my screen. I think yes. Okay, so moving on. So what you are given in this question is I've created a representation pictorially, so I'll tell you from here. So what you are given, this problem statement says that you are given three towers, okay, and three discs that you can see here, okay. The discs that you can see here are in decreasing order of their size, okay, right, if you go from bottom to top, okay. So what do you need to do here? You need to move one disk at a time. That is the thing that you can do. You can move only one disk at a time, and you have to eventually move all the given disks from rod A to rod C. So you can consider that the rod at which all the disks are present initially is your source rod and C is your destination rod, okay. And why you have been given one more rod is to make use, while you are trying to transfer one rod to the other, from one rod to the other. The reason is you can only move one disk at a time, okay. Now let's see how can you travel all the disks from source rod, that is A, to the destination rod, that is C, okay. So what are the possible ways? What if I move my rod, my disk 3 at which rod? Let's try to move it at rod C, okay. Let's see what we are doing. Now you have two rods at A. What if I move my disk 2 at rod B, okay. Now let's take this disk from rod C and move it to rod B. Now I have a space empty to put my disk 1 to rod C. Why have I done so? I wanted to bring all the disks in the same order to the final destination rod. So the first thing that I would want to do is that bring your disk number 3, which is the maximum size disk in C, so that you can further put. Now what do you see? Don't you see here, now you are left with two disks in the same order as they were present in your source rod, right? Now do the same thing again. What are you going to do? Let's try. We did something like similar to this when we were present with three disks on rod A. Now we are left with two disks on rod B, and finally we want to move to C. So here I have this rod empty, so why not make use of it? So what did I do? Let's move this particular disk at rod A. Now I am left with this disk at rod B, so I can move it directly to the destination, right? Now in one go I will also move this one to this position. Now wait. Okay, these are some steps I did, but what is important for you to understand the steps, not the representation of before and final steps. You need to understand the steps that we were doing meanwhile. Let me cut this question short to if we had only three disks at a time. So if we had two disks at a time, how would it look like? Just imagine, just forget that. See, this is in the picture that this A is your source and C is your destination. Just imagine that this is your source and this is your destination. Again, what you will need simply two rods. Why? Because for one rod as your auxiliary rod, so that I can put my topmost disk at some position which is not my destination rod. Why? Now what I am telling you to understand, that consider for example, you are at C, you have to finally bring all the disks from C to A. So what you are doing, at first step, if you have total two discs, in that case you are moving your disc number 2, let's say this is your disc 2, from C to B, right? That's what you are doing. And see, I am telling you this in an unconventional way. Why? Because in most of the examples, most of the discussions, we do it from A to C only, but I just randomly picked from this rod. The reason is I want you to understand that you just need to understand that what is your source, what is your destination. It need not to be always you fixed some pictorially that this is your A, so you bring back wherever you are. You just need to understand. It can be in any order. Source, destination, auxiliary rods can be in any order. You just need to understand what is source, what is destination, which is your auxiliary rod. Okay, so just imagine that C is your not destination now. Let me just erase it. I just don't want you to get confused. I can take it in back in conventional way. So let's go back to conventional way only. Let's not make any confusions. Okay, so we have two discs now. Let's say we have two discs now, rod number 2, disc number 2 and disc number 1, correct? Fine. So one second. So this is your 1 and this is your 2. So initially both were present here, right? Initially both were present here. So what I did, I moved your disc 2 from A to B, where simultaneously I am writing this is your source and this is your auxiliary. Your target is to bring all the discs from A to C finally, right? So initially you move this one disc from A to B. Why? Because you want to move finally the disc which is at the bottommost of your source rod to go to the final destination rod. So I need that rod to be empty. So now I have only one rod, I have only one disc which I will move. Okay, so if I move this disc now, if I move this disc from source to destination, what step did I take here? I moved basically, now I moved my disc 1 from A to C, that is your from source to destination. Now what am I left with is, I am left with my disc at auxiliary rod. So now you will move your remaining disc, that is disc number 2, from B to C, where B was your auxiliary disc and C was your destination, right? So when we did this thing for 2, it was very easy for you to understand, right? Now we are doing the same thing for 3. So what difference are we making? So if let's understand it in this way. Now I'm taking back the 3 rods. What I want you to understand is that how we are repeatedly doing the same thing again. For that, now you know how we moved 2 discs. Now I want you to know how can we move 3 discs in the similar pattern. So let's understand it. Let me bring back my discs here. Okay, so what do you need to understand is, when you had 2 discs, you were doing for 2 discs in the way that I have written here. Now if you have more than 2 discs, how you are managing it? Your target is, let us assume that this is one set of discs. Again, let's say this is disc 1 and these all together are discs 2. Just take it as a cluster of disc 2. So now you are again left with question of taking 2 discs to final destination rod C. So what were your steps? You were taking disc, okay, let me make it disc 2, this is 1, that was 2. So what was your first step? You bring disc 2 from A to B. So when you will move this cluster of 2 from A to B, how is it going to look like? It is going to look like this entire cluster. Just imagine this entire cluster coming to auxiliary rod via your first step. Fine. Now your second step is that you move your disc 1, which is this disc, from A to C. So if I move it from A to C, it will be like this. Now it says your disc 2, which is actually a cluster of discs in this case. So move this cluster finally from rod B to rod C, right? So don't you see this pattern, repetition, this smaller, we are actually solving for smaller sub problem, and then we are using this for a final answer. Now you will ask me, how are we using it for smaller sub problems? So what we had was, first let me, now you know that we can move this entire cluster from here to here, right? But wait, now how are we going to do for two disks? Basically, if I know in how many ways can I move two disks, in how many ways can I move two disks from auxiliary, from some rod source, here B is acting as source, from B, which is acting as source in this case, to final rod, that is C, which is acting as destination. And here in this case, when I am solving problem for two disks, see, I want to know in how many ways am I moving two disks. I know I am treating it as a cluster of disks, so I am solving the problem for two. But internally, recursion will have to tell me in how many ways can I move two disks from a particular rod, which is B this time, your source will be B this time, and I want to move it to some destination where I will be using A as my auxiliary rod. So can my recursion not do this thing? Yes, definitely it can. We know how we were solving problem when I had two disks. So in this case, how many ways was it using? For two, how many, if I have two disks, how many ways I had? I had three number of ways. What was that? Recursion will solve problem for these two disks, and that number of ways is, you first move your topmost one to auxiliary rod, right? Look at the step number 1. This is your one way, this will count as one way, so 1 plus, what is the next way? You move your final disk, which is disk number, this one particular, from source to destination. So here your source is B and destination is C. So this is another step, counting it to another step 1. Now the final step is, you are moving your disk, don't go at disk 1 or 2, you just see now your disk from auxiliary here was A, it is moving to final destination, that is C. So one step will be added for that, right? So total how many ways did it take? It took 3 ways for 2 disks, right? Plus 1 equal to 3. So in 3 ways I was able to move this cluster. So cluster of 2 disks took me how many ways? 3 ways. And to move 3, how many rounds of movement will it take me? So if I come back to my original problem of solving for 3 disks, I had initially this one, so I had it like this. Wait, let me bring it back. Let's see for 3 in how many ways am I moving it. Okay, just one final dry run over this, and then we will move to the code. Okay, so now you know for 2 disks at any point in time you have 3 ways to move from source to destination. So in how many ways was I moving it? First of all, I was already doing this thing for the first 2 disks, and if I want to move the first 2 disks, for that what I am doing is, first I am moving this particular disk to, so what am I doing? I am moving it at final destination. So one step of this simultaneously write also. So 1, okay, let me write it like this, 1 plus, we will see. Now I am moving this disk. Now let's move your disk number 2 to rod B. Now this will count for another one, that is 1, fine. Now what you are doing, you move this disk from here to here, so this will count for another 1 plus 1. Now you have this disk as empty, so you are moving what? You are moving your final disk from here to this rod, right? So count 1 for it. Now the question is left back for moving 2 disks from source, where source is B, to destination, where destination is C. Doesn't recursion know already how to solve number of ways, how to find number of ways to move 2 disks from one rod to another, where I have one other rod as an auxiliary rod? Yes, so I can make the same call for now n minus 1 disks, and it will give me how many ways? 3 ways. So I will add this to the answer that I calculated for my movements. You getting it? So you do one part for one disk on your own and ask recursion to tell me in how many ways I can move n minus 1 disks. Now no matter you have 4, 5, no matter how many disks you have, you do calculate answer while you are moving one disk and the rest as one other cluster of disk, and ask the recursion to solve problem for the remaining disk. So how much is this giving you? 4 plus 3, 7. So if you check your sample test case in your question, the number of ways for n equal to 3 disks should be 7. Is that right? So let me just see if you guys, okay, there is lag. Okay, lag shouldn't be there. I'll check my network next time for the lecture. I think there's some network issue. Okay, so let's move to the code right now. Now from once I'll write the code is very simple. Before let's just code, then I will tell you what is the time complexity. I'm sure you can guess the time complexity also now very easily, but okay, moving on. So you have this, what I told you. Let's make the base case condition. If your n is equal to 0, what you should return 0. There are no ways to move 0 disks. Fine. Now you calculate answers for your own particular. So let me take long answer as 0 because you want to return long type of answer. So answer is will be calculating the number of ways for me. So what is the first way? So my first way is that I am calculating in my answer ans plus equal to. What am I doing? I am calling this recursion call, right? I'm making this recursion call for n minus 1 disks, right? To move from your which disk. So you were moving it from your source rod, that is your from rod. You were moving them in order to ask recursion to calculate the number of ways for 2 disks. What you wanted to do? You wanted to free up this source rod. So for that you wanted the n minus 1 rods to move from source to auxiliary by making use of destination rod. Remember, how did we move 2 disks to rod number B? By making use of rod number C. So your target in the first step would be to move n minus 1 disks from your source rod to this is your destination rod. So your destination rod in this case will be your aux rod, and you made use of your destination rod, right, which is your 2 rod. Okay, right? And then you got, in this way you got your rod number A, rod number source rod free from the n minus 1 disks. So you took one step was taken to move from A to C, correct? So you will add that 1. So ans plus equal to 1. Then the last step was, now what you are doing, you already have your biggest disk on the destination disk. Now you want n minus 1 disks from which rod? Your auxiliary rod to your destination rod, where your A will become your auxiliary, means from this B rod to C rod, making A as auxiliary. So let's take its convention, call recursion for the n minus 1 disk to move from. Now what is their source now? What is their source right now? Their source is the auxiliary rod. So auxiliary is the source. Destination is there 2 only. I want them at 2 rod, and now I will make use of my source rod, that is your from rod. Okay, fine. But wait, they want answer number of ways as well as what steps you took. So let's also do some printing. So let me print system.out.println. What am I printing? I will print move. So they want it this way, move disk like this, move disk, right? Plus you want it from, you want how many disks, which disk at that point in time, n, plus from rod, okay, plus which rod it is, from, plus 2 rod, plus 2, the rod number exact. So move disk, which disk it is, from rod from to rod 2. That's what you want to print. Let us check. We want to return final answer. So let's see. What is the error? Capital N is given, I have taken small, so let's change the argument. Anything else? 45, same thing. That's all. Move disk 1 from, there are no spaces. Move disk, I have to add some space. From, let us check now. So we are done with this question. That was all about this question. So if you have any doubts, you can write in the chat. And apart from it, let's understand its time complexity. So at any point in time, whenever you are moving any rod, so for any rod that you were moving, this is your any disk that you are moving from any rod, this is your rod B, this is your rod C, this is your disk, let's say. So your each disk has how many options? Whichever disk you are moving, you always have two options. Either you can take rod B or you can take rod C. Let's say if your disk is at rod B, now again you have two options. Either you can move it to rod C or you can move it to rod A and then finally to C. Anything you can do, but at every step, every disk has two options of rods. The rods will be the rods at which it is not present. So each rod will be having two options, two rod, let's say. So if this is your disk 1, so disk 1, disk 1, disk 2, each of them have how many options? Two options. This like this. So 2 into 2 into how many disks are there? Let's say there are n disks. So multiplied by 2 n times. So that is 2 to the power n. So your time complexity will be big O of 2 to the power n. So it's time complexity of big O of 2 to the power n. The reason is each disk at any point in time has two options, and the two options are going to any of the rods at which it is not currently present, right? So that is the time complexity. We are not using any extra space, no space complexity, just the stack space of recursion that internally memory is using. That's all. Any doubts, you can ask me in the chat, otherwise we'll wrap it up. So I think that's all. Okay then, see you all in the next lecture. Try to do it yourself. The code is very simple. You just need to understand how recursion is working. The entire problem is on understanding how recursion is taking place. Okay, so try to decode it yourself. Now you already know this how to do. Just try it.